As we continue to work with parallelograms and, of course, quadrilaterals and the special quadrilaterals into parallelograms, we want to not only be able to identify what a parallelogram is, but we are going to use those characteristics of parallelograms to prove that quadrilaterals are a parallelogram. So how can you prove that a quadrilateral is a parallelogram? So let's talk first about some of those properties that we've already identified. So we know that the properties of parallelograms, so looking here, and we have this quadrilateral A, B, C, D, and it's a parallelogram, and we can identify that it's a parallelogram because we can see that my opposite sides here, looking at AD and BC, we can see that they are parallel, and then AB and DC are parallel. And what we do know too, that they are not only parallel, but they are also congruent. So this side is congruent to that side, and this side is going to be congruent to that side. Opposite angles, we can see here that opposite angles are also congruent, because if we look here, opposite D is opposite of B, and we have two congruency markers, and then C is opposite of A, and we have one congruency. And then we learn too that, of course, this angle, this angle plus this angle is going to be 180 degrees or supplementary, but let's not go there yet. But we know that the diagonals bisect each other, so they will bisect each other. So in bisecting, let's see, we have a diagonal from BD, we have a diagonal from AC, and then they will bisect each other, creating this point right here, which would be point E, or if we were to label it. And then I know that AE is going to be congruent to segment EC, because that is the definition of bisecting, to cut something in half. And then, of course, we have segment BE is also going to be congruent to segment ED, because again, it was bisected, so that means it cut those in half. So just looking at some of these characteristics, and let's see here, those are the properties of parallelograms. Classifying a parallelogram now, classifying a quadrilateral now as a parallelogram, looking here that we know that this quadrilateral, in this example, A, B, C, D, is just that. It's a quadrilateral. And I know that AB here is going to be congruent to DC. And also that AD is going to be congruent to BC. Let's see, because of course those are some of the properties that we know. And then, is this a parallelogram? Well, according to our definitions above, congruent, 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 I'm not sure. Let's see here, but we do know that, I'm kidding. We know, is ABCD a parallelogram? I think it meets our definitions. And then we know that triangle, let's see here, looking at it using our side congruency, we know that triangle ADC, let's see here, so we're going to go with triangle ADC should be congruent to CBA. So there we go. It looks like that diagonal AC has created two congruent triangles. Now, the converse here is if both pairs of opposite sides both pair of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Parallelogram. Okay? Because again, guess what? If my opposite sides are parallel and congruent, that's one of the properties of a parallelogram. Therefore, if both opposite sides are congruent, then it is a parallelogram. So that's that converse, right? The if going forward and back with our statements. So here in this case, we have if PR is equal to QS, right? We can see that, right? It's equal to QS. And then PQ is equal to RS. Then PQRS is going to be a parallelogram. There we go. Using those properties and identifying those properties to understand and to see what we have. And we just want to remember that, how can you prove that a quadrilateral is a parallelogram? Well, we're going to take those properties and apply the converse to that, which allows us to bring that all together and prove that a quadrilateral is a parallelogram. Now we talk about the angle theorem and the converse of the parallelogram angle theorem. If both pairs of, remember the properties before where we talked about opposite angles. So if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram, and we can see here that this angle B is opposite of angle B, and they're congruent. Angle A is opposite angle C, and they are congruent. So as we look here, if angle A is congruent to angle C, so the measurement of angle A, right? In this case, I guess I probably don't need to have that. Let me get rid of that and get rid of that. If angle A is congruent to angle C and angle B is congruent to angle C, then therefore we are going to have ABCD is going to be a parallelogram. Continuing on with the diagonal theorem. So the converse of the parallelogram diagonal theorem is we know that the diagonals bisect each other in a parallelogram. So therefore, if the diagonals of a quadrilateral bisect each other, then that quadrilateral is a parallelogram. Again, we are moving forward and back through our theorem. So we look over here and we have A, B, C, D, and my diagonal here is bisecting each other at point E, and I can see that AB is going to be congruent to, not AB, sorry, AE, goodness, is going to be congruent to EC, and DE is going to be congruent to EB. So we have those segments are being bisected, therefore E is a midpoint. We can see then that we are going to have a parallelogram. Let's see here. As we move on, we're going to talk about the single opposite side pair theorem. Okay. If one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. Let's see. So we have one pair of opposite sides of a quadrilateral and is both congruent and parallel. then the quadrilateral is going to be a parallelogram. So opposite sides. So let's see here. It says if AB is congruent to CD, AB is congruent to CD, and AB is parallel to CD, then ABCD is going to be a parallelogram. And then if AD is congruent to BC, and AD is parallel to, goodness, AD would have to be parallel to BC, then ABC is also going to be a parallelogram. So again, in this, we are looking at some of the properties of a parallelogram and being able to identify those properties in a quadrilateral, therefore proving that we have a parallelogram. And right here we had the opposite parallelogram angle theorem. So we talked about opposite angles of a quadrilateral. If we had opposite angles of a quadrilateral are going to be, of a parallelogram are congruent. So if we have a quadrilateral who have opposite angles that are congruent, then it becomes a parallelogram. Here we talked about the diagonals bisecting each other. If we have a quadrilateral and the diagonals bisect each other, then we have a parallelogram, because that's a property of parallelograms. And then sides, if we have one set of parallel congruent opposite sides, then we are going to have a parallelogram, and that's going to make the other set parallel and opposite. Parallelograms to identify quadrilaterals that were parallelograms. So looking at some examples here, applying properties of parallelograms. In this example number 1, it says, what is the perimeter of parallelogram KLMN? So here we go. We got KLMN. And if it's a parallelogram, then we know that opposite sides are congruent. So if opposite sides are congruent, then I know that if LM is 45, I know that KN is going to be 45. If KL is 31, I know that NM is going to be 31. So now in order to find the perimeter, of course, I'm going to add all my sides up. So my perimeter is going to be equal to 31 plus 45 plus 31 plus 45. What are we going to get here? We're going to have 76. So 76 plus 76 is going to be 152 units. So that is my perimeter. Now I can tell you what do we know, some of the other characteristics. If I just wanted to look at this picture beyond the question, if it's a parallelogram, I know that this angle, opposite angles are going to be congruent. Therefore, angle L is going to be 119 degrees. I also know that angle L plus angle K is going to be equal to 180 degrees. So I could find that this angle K is going to be 61 degrees, and then opposite angles would be congruent. So then we have K is congruent to M. Again, that's beyond the question that was asked, but those are some characteristics that we should be able to recognize. Let's see here. Example number 2. Find the value of x for JKLM to be a parallelogram. So what is the value of x that would prove that this quadrilateral JKLM is a parallelogram? Well, in that case, we know that parallelograms, look at these two sides right here. Those two sides are opposite sides, and we know that opposite sides in a parallelogram are going to be congruent, which means their measurements are equal. So we could say in a parallelogram that if KL is congruent to segment JM, we would have a parallelogram. So we can simply do some substitution, and we know that KL is 7x minus 2. And if that is equal to 12x minus 22, that would prove that we have a parallelogram. So what would the value of x be to make those two things equal? All we have to do is combine like terms now and simplify. So I'm going to go ahead and subtract x on both sides to get my variables together. 7 minus 7 becomes 0. Go ahead and bring my negative 2 down. And 12x minus 7x is going to be 5x. I'm going to bring down my negative 22. And continuing to combine like terms, I'm going to add 22 to both sides. Because I'm trying to make that 0, I want to move it over to the other side by using inverse operations. So I end up with 20 is equal to 5x. Divide both sides by the coefficient. And x is going to be equal to 4. So there you have it. We have, if x is 4, then we have a parallelogram because those two sides would be congruent, which is one of our properties. And if we were to plug that in, we would know then that 12 times 4 is minus 22. Let's see, this is 48 minus 22 is going to equal 26. So JM, which is equal to JM and KL should both equal 26 for it to be a parallelogram. What is the measurement of angle C in parallelogram ABCD? Well, we know that parallelograms, if you look here in ABCD, right? ABCD, we have opposite angles AC. For a parallelogram, opposite angles are going to be congruent, which means they're going to equal. So I know that angle A should be congruent to angle C in order for it to be a parallelogram. And so do some substitution. And I'm going to say that 6x minus 15 is going to be equal to 4x plus 11. And now finding the value of x that would make these parallel. Okay, so as we continue on solving this and combining like terms to figure out what x is, because I need to find out what x is in order to figure out what in the heck this value is going to be. So I'm going to combine like terms using my inverse operations. 4 minus 4 is going to become 0, so I have 2x minus 15 is equal to, bring down my 11. I'm going to add 15 to both sides, and that is going to be 26, 0, 2x. Divide both sides by 2, the coefficient, and x is going to be 13. Well, I found x, but I have not found the measurement of C yet. So I'm going to go ahead and substitute in 13 for the value of x and be able to figure out what my measurement of my angle is. So here I know that C is 4 times 13 plus 11, so that would be 52 plus 11, or 63 degrees. Okay, so now we were able to find out that angle C is 63 degrees. Let's look at this last quadrilateral, and it says that the quadrilateral NPQR is a parallelogram, okay? And then if NS, they have given us this segment, of NS, and they have given us SQ. All right, so if this is a parallelogram, they want me to find this entire length. They want me to find NQ. Okay, if this is a parallelogram, then we learned that our diagonals bisect each other, which means they're equal. So what I can do, I can say that I know that NS is going to be congruent to SQ since it's a parallelogram, and I can do my substitution now. So we can say that NS is 2x plus 7, and that is equal to SQ, which is 5x minus 23. And we can solve for x, and once we solve for x, we can figure out what the unit measure is for NQ. So let's see, combining like terms, I'm going to subtract 2x from both sides. That will become 0, and I will have 7 equals 3x minus 23. Let's go ahead and add 23 to both sides to combine like terms. And that becomes 0, and I have 30 is equal to 3x. Divide by the coefficient, and then this becomes x is 10. All right, well, if x is 10, I know that I can now solve for NS. So NS is 2 times 10 plus 7, 27. And SQ should be the same. SQ is 5 times 10 minus 23, which is 27. And we know that NQ is equal to NS plus SQ. So we know that NQ is actually 54 units. There's different ways to calculate that, but knowing that those two segments added together would be the longer segment, that's my segment addition postulate. So there we go. We know that NQ is going to be equal to 54. Now that that car is left, NQ is going to be 54 units. 54 units. So as we sum up, or we look at all the different characteristics of the parallelogram, we're able to use those characteristics to prove that other quadrilaterals are parallelograms. So here, as we finish these up, so we applied those properties that we are using with